This fixturing follows the original set of holes that were put in the guitar top at the time we began construction. This will ensure the accuracy of the center line down through the neck into the guitar body. The purpose of notching the kerfing to allow the brace to fit into it securely and snugly is to transfer the energy that will be developed at the bridge and push down in and set and continue the motion of the back and side. We're connecting the whole unit to form an active resonant chamber. Where the excess wood is trimmed off the body, top and back, getting ready for the neck fit and the rabbiting for the binding of the body. The areas that were just worked on are to ensure that when the binding slot is cut, the rabbet in the edge of the guitar body, that the entire cut will be uniform and require no handwork. Now we're facing off the shoulders of the guitar based on the center line of the guitar, which was established by the two pinholes that are drilled in the face. We next go to the dovetail machine, and the dovetail will actually be routed into the body on this shaper. Once the dovetail has been cut, then the body is placed on this sanding device, which ensures a perfectly flat surface for the fretboard to attach to the guitar. This is required because our guitar tops are built with a 28-foot arch at the top, a parabolic dome basically, but we need a flat spot to adhere the neck to. The use of the hand sander blends the line that was left when it was faced off perpendicular to the center line. This tool is used to determine if the pitch of the neck backwards was adequate and squared to the body. Next operation will ensure that that dovetail and the face-off of the shoulders were actually perpendicular to the center line. Once the accuracy has been established, the height of the required bridge is noted on the inside of the dovetail. They'll check that height, that neck fit, to see if there's been any movement in the body. From here, the operator takes the guitar and cuts the rabbet in it for the actual slot to glue the plastic edge binding in. This cut that's being done is for the 1/4-inch binding that'll go around the outside of the guitar. The next cut will be a purfling cut, which is a decorative stripe that actually are placed in the guitar to free up and loosen the top so we get more acoustic effect from the pumping of the guitar when it's being played. Get to see the binding of the guitar. This is where the protective edge is put on that allows sort of a shock absorber. We also include purfling on the inside to loosen up the top and allow it to move a little bit nicer. We want to increase the potential for the acoustic effect of the movement of the guitar top. Here we're using a solvent-based glue that will actually melt the plastic and marry it into the fissures of the grain of the wood. You'll notice a difference between the method that we use here and that in Nashville, where they use the bias tape to wrap the guitar. You can do that on a solid body with no injury to the instrument, but on an acoustic, there's no way that we could put that kind of torsion into the guitar body without the possibility of a damaged veneer. The very edge of this extruded piece of plastic that we use has a bevel cast into it, so that gives us a place for the solvent to go when we put pressure on it. It allows for a good clean glue joint and gives us a cure time that is lengthened, so we get a good bond. By wiping off the excess glue and not having the cords like they have at Nashville, we get a much cleaner job, and it requires almost no scraping to get this guitar ready to sand. The glue that we use has a highly accelerated melt and cure time. So it attacks the plastic and allows it to meld into the wood fiber or grain and then cure very rapidly. So this is ready to scrape tomorrow morning.